Hi, I am Sukrut Rao from the Max Planck Institute for Informatics, and I will be presenting our work in which we study how to efficiently and effectively guide models using explanations. Despite being highly performant, deep networks often rely on spurious features. For example, to classify a bicycle, a model may rely on the person that commonly co-occurs with it, or to recognize a bird, it may rely on background features corresponding to its habitat, as seen from the model's explanations. This reliance leads to poor generalization, and so we need to ensure that models are not only right but are so because of the right reasons. A way to address this is to guide models using human annotations. Here, while training, in addition to the standard classification loss, one also uses a localization loss which aligns the explanations with human annotations. This can be helpful for redirecting the focus of the model to the desired features. In our work, we focus on making this guidance more effective and more efficient. For effective guidance, we perform an in-depth study across various design choices. Across evaluations, to perform a fair comparison across these choices when evaluating both for classification and localization performance, we plot and compare the Pareto front of models for each configuration across varying weights of the classification and localization loss. Overall, we evaluate across evaluation metrics, where we use the EPG score to evaluate focus on the object and the IOU score to evaluate focus across the annotation mask. Across loss functions, where we find that the energy loss is effective in directing the model's focus to regions over the object, yielding high EPG scores, and the L1 loss is effective in directing the focus across the annotation mask, yielding high IOU scores. We also evaluate across various model types, including inherently interpretable models, and find that BCOS models show particularly high improvements over the EPG score, and across attribution methods, and we find qualitative improvements in focus across all of them. We also evaluate across guidance depths, which determines at which layer attributions are computed, and across datasets, including multi-label datasets such as Pascal VOC and MS COCO, and also Waterbirds, where we show that guidance, particularly with the energy loss, is effective in redirecting the model's focus from the background to the bird and improving accuracy on out-of-distribution data. For our second contribution, which is efficient guidance, we focus on reducing the cost of performing model guidance. Across our experiments, we use bounding box annotations, which are cheaper to obtain than fine-grained segmentation masks used in most prior work. We also evaluate using coarser bounding boxes during training and find that guidance with energy loss remains robust to coarse annotations. Additionally, we evaluate using limited annotations, including annotating just 1% of the data, and find that it still provides significant improvements over the baseline. The experiment on the Waterbirds dataset shown previously also uses only 1% annotated data. Finally, we vary the guidance depths, that is, perform guidance using explanations at deeper layers of the network, and find that this provides similar gains in performance while being twice as fast. Overall, in this work, we focus on making model guidance effective and efficient. Please refer to our paper for more details and full results. Thank you for your attention.